Okay, one last talk. Cem Turan is going to be talking about building an app using Reason. He's actually been a long-time Expo user. He's experimented with Expo in the past, but only recently was he able to actually use it for building an app for production. So he's used it at his company and built an app using Reason and Expo. So I think he's going to have some really interesting insights to share. So let's give him our attention. Thanks.
Cool. Thanks. All right. To begin with, I'm kind of mind blown. Like, there's been like 20 talks, and I'm like impressed by you that you're still here. Yeah, and I just want to give a like huge applause to the team and all of you. It's pretty amazing, I think. So, a few disclaimers before I start. I want you to be super critical of what I'm presenting, and I want you to also like think about, is what you're doing right now actually a good way of doing it? And you also have to remember, like, all the different solutions presented, there's rarely a silver bullet. There's rarely like a one-size-fits-all solution. So what I'm presenting here worked for us. It might not work for you. And lastly, some of the examples I'll give talk about TypeScript and other solutions, and things might have changed since I looked into these things. So I invite you all to like verify everything I'm saying. Yeah, so with that out of the way, I think untyped JavaScript should be considered harmful. Not only to your code base and to your mental health, but also, you know, the health of your future colleagues. You don't want to be delivering legacy code every day, right? And yeah, I think it's also unethical. So I think, so it's also super important, not only like for yourself and for your code base, but also your business and also the end users who are the people getting, you know, the null pointer exceptions and undefined is not a function. I think we can do much better. Hi everyone, I'm Cem. This is my Twitter handle. I think we need to make this a little bigger. And I'm here to talk about a more reasonable way of doing React Native development and development in general. So my story started in September, where I started doing ReasonML full-time. I joined a team with a good, run by a good friend, and somehow managed to convince them that ReasonML would be a good bet. And one of the ways I did this is by also providing a fallback strategy. So the idea was to start off, give ReasonML a try, and if things didn't work out, there was technologies in place that could allow us to fall back to another language, such as TypeScript, and still use some of the code that we produced in ReasonML. Spoiler alert, we didn't have to do this. And I think at this point, like 98% of our code base is ReasonML. This, of course, in some cases excludes external dependencies. So this is the journey towards a more sane, functional, and sustainable development workflow. So how did we do? One of the ways I alluded to in the title previously, and it's about creating a more sane environment. And one of the ways to do this is to have a solid foundation that you can trust that everything you're typing in the end is also what is being run. You need static typing for this, and you need soundness in your type system. In other words, the compiler should catch your mistakes and not the runtime. You want it to fail fast so you can fix it and move along. I'll just make this a little bigger. John DeGose is one of my heroes. He is a functional programmer and works in Scala mostly. And what he argues here is that over time, when your code base grows and complexity increases, you need certain guarantees. You need to maintain a consistent velocity. The more you accelerate without a type system, the more does anyone want to give a guess to what happens? Your speed decreases. So okay, that's weird. Kind of jumped. Okay. So for whatever reason, my presentation jumped 50 slides ahead. All right, let's start again. No, I'm kidding. Okay. All right. Another of my heroes, and one of the most amazing moments I've seen in a conference, is Philip Wadler. And he is he's the person who introduced monads, if you've heard about this thing, to functional programming. Previously, it was a concept in mathematics. And he introduced this in 1995. And it's just now making it into the mainstream, at least in JavaScript. So I think these people are not only heroes, I think they are superheroes. Not because of things they have in their tool belts, such as monads and pro-functor optics. I think it's because they have a solid foundation on which they can build upon, and they can reason about their code compositionally and also locally. They rarely have to worry about one change in the context you're working on, in the module or the function, affecting other parts of the system. Usually the side effects, they are contained, and in some cases, most of the code you're writing is purely functional and side effect free. But if this was the case, like if we only wrote there wouldn't be any outcome. You need to do side effects to do something useful. So one technique is to isolate and do a bit like React. So React has this declarative model. You can model effects the same way. So as a tree of things that happen. And then you have a runtime or an interpreter. But enough about this. I will give you a pointer towards this later. But this is not required to be productive or even be a functional programmer. And I think this is why Reason is the right choice. So Reason is created by Jordan Walk. You might know him from React.js. He prototyped React in SML, which is a functional programming language. And it's a pretty ancient language. So it was a bit of a hard sell to, tell people to use this ancient language. So what happened instead is a rewrite in React.js in JavaScript happened, and came to know as React.js. But Jordan came back again, and I really like this tweet. So he says, "I like how Reason community isn't gatekeeping. Anyone who writes JavaScript or TypeScript should be able to get started immediately, and the language should nudge them to fewer mutations and enforce total safety." I think OCaml has been very pragmatic from the start too. And I think the important aspect of this is that you don't have to buy fully into the functional and, purely functional mindset. You can take liberties and do imperative things. You can do console logs wherever you want. And there's also a quote here, the last one, that also states that OCaml, like these liberties, allow you to be more productive and won't require you a lot of upfront learning or a change of mindset. All right. So I mentioned OCaml, and the reason why is that ReasonML is based on this language. It is a alternative syntax and a tool chain on top of OCaml. And what do I mean by tool chain? Well, it is basically a syntactic. ReasonML has this tool called reformat, which you can think of as the predecessor to Prettier. So it allows you to not only prettify your code and maintain a consistent style. In this case, we can convert ReasonML code to OCaml code. And there exists a OCaml to JavaScript compiler called BuckleScript, which is being utilized in this toolchain to go from ReasonML to JavaScript. And ReasonML has a familiar syntax, so it, in my opinion, looks like JavaScript. It has somewhat the same semantics, and you use the same environment you're used to install the dependencies. So you can use yarn and npm. And you might be asking yourself, like, why did they pick OCaml? It is a fairly old language. And one really good reason is that it has a rock-solid type system. So OCaml types at all time have 100% coverage. And this is even though you don't explicitly write annotations everywhere. OCaml code and ReasonML code requires very little typing in terms of types because there is so good inference. So I think of it as a nice middle ground between the productivity you get from JavaScript and the safety you get from types in, for instance, TypeScript or Flow. And ReasonML is also sound in terms of the TypeScript, and TypeScript, is sound in terms of the types. And TypeScript has made a conscious trade-off here that you can read about if you're interested in it. And it's also one of the reasons why some people prefer Flow. So I think ReasonML in many ways is ECMAScript 2030, and that's being like very optimistic. It's probably more like 2040. So let's take a look at some ReasonML code. I'm not sure if you can read this. Are you able to read this? Yes? No? Okay. So what you see here is Reason React. So this is how you would go about working with React in Reason. You start by creating a component, which you can think of as an object. And you have your make function, which is how you represent your component with its parameters. So you have a name. Then you spread the component here, and you override the render function. All right, and what we saw on the previous slide was a stateless component. In Reason, you also have a reducer component, so you can hold on to some state. And the way you do this is by declaring the actions you might have. So in this case, we have a way to increment, a way to decrement, and to reset. And one cool thing is that ReasonML also has pattern matching, and it has the feature of being exhaustive. So the type system will tell you if you forgot to handle a case, which we did here. We forgot to handle the reset case. And here is the actual component. We give it an initial count, and the tilde here is a way of declaring named arguments. This is how props are represented. And you can also give it a default value. So we give the reducer component an initial state, the reducer we saw previously, and also a render method. And here we have access to the state and send, which you could think of as dispatch in Redux. And one thing worth noting here is that Reason also has a piping operator, and it does not have any implicit coercions or conversions. So in JavaScript, you might be used to you being able to give a conditional, an if statement, a number, and it will then coerce this or convert it to a Boolean. And there's no such thing in a Reason. So you have to handle these cases explicitly, which in my opinion is a good thing. All right. And what you might have noticed in the reducers was that there are different things you can call there. So there's a way of declaring this should not trigger a re-render with no update. Update, which sets the state and re-renders. And also a way of declaring side effects. And also a way of updating. Sorry. So there's a way of enqueuing side effects. And the reason why you might want this is because in the future with concurrent React, you want these things isolated. And speaking of the future, hooks landed in Reason React less than a week ago in master. And this gives us some really cool things. So, as you might know, use reducer, use effect, use context, etc. And even nicer is how much it simplifies React in Reason. So here we actually just think of it as a functional component, as we do when we work with hooks. Here's an example with a prop called message. We can use effect, and what we return here is a cleanup function. In this case, we don't really have any. We don't have anything to clean up, and this we tell, or this we here we either have to return something, which is a cleanup function, or we have to return none. And this concept comes from the option type. So in Reason and OCaml, there's no such thing as null and undefined. You have these constructors instead that encapsulate that kind of logic. So what about React Native? So Reason React and also Reason ML is largely a Facebook open source project. It's being used internally at Facebook. Whereas the React Native project is a community-driven project. And just recently, we've also seen a rewrite of BS React Native. And it's the one you can think of as with hooks. So BS in this case doesn't stand for what you think. It stands for a buckle script, and it's basically just a convention and just a way of making it easier to find bindings for libraries on NPM that work in Reason or target Reason. So this is the result of the rewrite. 0 cost. So on the left, you see some of the runtime overhead of the first version of React Native for Reason, and the second one is literally no code. All right, so some other cool things worth mentioning with regards to Reason is that you have some nice operators. So if you've been doing some functional programming in JavaScript, you might also have come across a proposal for adding pipes, the pipe operator. And Reason ML and OCaml already has these features. So these are 2 variants, and they basically describe they allow you to put either the argument on the left or right hand side of your function arguments. Another cool thing is that you can define your own custom operators. You should not be doing this like nilly-willy and like everywhere. it can get out of hands pretty quickly. And the reason why is because they're not always super descriptive. That being said, I think it might make sense to use it in, for instance, this use case. So if you're familiar with a reanimated, you kind of build up this tree of instructions, and sometimes it looks a bit weird or not what you're used to, with a lot of nesting, and that's basically because you don't have any operators, which you would be used to normally. So one thing you could do is you could, in a ReasonML, specify some of these operations as operators, which might be much more familiar to you. So you could have a plus, minus, multiply, and also a way of setting, etc. All right. So how do you get started? It's fairly simple. So you add BS Platform, which contains the compilation toolchain, Reason React, the bindings for React, and then you have BS React Native, the bindings for React Native. Then you can go ahead, create a source folder, create a BS config JSON file. This just has some instructions for the buckle script compiler. You give it a version of the JSX syntax used in Reason. This is a way which the Reason team has been pushing for changes in the syntax. And a very cool thing about these changes in Reason is that because of the type system, you're able to provide code mounts. So a lot of changes in the type system and to Reason React, you have been able to upgrade with very little manual work or rework. You have to specify the buckle script library dependencies you have. So BS React Native, Reason React. You define your source folder, and then you also specify that where you want the output. So the compiled JavaScript. So when you write in source, they will be placed right next to your Reason files. Yeah. So here's one very small, silly example. This could be your entry point and where you have the rest of your application. And you would then you would simply just require this from your normal, JavaScript index. And there are a few instructions to build, to compile the Reason code, ways to clean it, and then you can also watch with the watch flag. Sorry. Yeah. And you also want a nice experience developing. So there are editor integrations in pretty much all editors. VS Code is the recommended way. I personally use IntelliJ and Android Studio. But there are also many other alternatives, and these give you some very common features you're used to and that you expect. Yep. And one worth looking into in the future is Onivim, and I'll get back to this. So what is the interrupt story? You don't want to rewrite all npm packages. So this is the latest and greatest way of doing it. This is a project called GenType, which is built by Cristiano from Facebook. And it allows you to basically add this annotation. And this you might also have seen previously with the hooks-based React components. And this is what is known as a PPX, so a pre-processing extension, which means you're actually able to take this code and transform it before you hand it over to the compiler. So this you can use to create to generate code, and it's basically generating the code needed for you to hand off types and talk to or expose, in this case, your Reason React component to a JavaScript project, and also a way of importing it. And this, I believe, will be merged into BuckleScript. We will have to wait and see. Reason Conf is happening next week, and I expect there to be some kind of announcement. Oh yeah, so one very important thing about GenType is also that it provides a way to generate TypeScript typings and flow typings. And this is the fallback strategy I alluded to in the beginning. This was the argument I used to convince my colleagues that Reason was a reasonable choice, and we had a way of falling back to TypeScript or Flow. All right. So another thing you also can do is create libraries in Reason. One example is Wonka by Phil, which is a Rx-like library. And the cool thing is it's written in ReasonML, compiled to JavaScript, and with typings for TypeScript and Flow. So this solves one of the issues of writing your code in, let's say, JavaScript or TypeScript, and not having a way of and having to maintain the bindings for both languages. So what does the future look like? React Native, really native, is a term I've heard before. And the idea is here to either do like the Reverie project by Brian Phelps, so who's the creator of Onivim. And what they're basically doing here is taking the React model and compiling it directly to native code. And here they are building everything from scratch. So they are rendering everything themselves from the very low level. So you can think of this like Flutter, if you've heard about that. There's Fluid by Jared, which takes more of a React Native approach. So you using existing components, but it still compiles to and interops with like macOS components and on Linux, or that could be a choice also. At last, the guys at Callstack have also been alluding to this thing. And it would basically be React Native without the JavaScript runtime. And ReasonML and OCaml is used for so much more than just React and React Native. So one of the main uses has historically been for backends. So it's been used in high-frequency financial trading. And another cool project Jane Street has is actually compiling OCaml code to FPGAs, so they can create high-performant routers, which I think is super interesting. And there's also the reprocessing project, which I encourage you to look into. It is a re-implementation of processing.js, and the reason why you might want to rewrite this in Reason is that you can now target native platforms, and also through OpenGL, and also target the web from the exact same code base. And another thing that was super useful for us in our project was the GraphQL bindings. The cool thing here is that this project makes an introspection query to GraphQL and generates all the types that match your GraphQL query. So you have full end-to-end type safety. Right. I have so much more to share, but like very little time. So I've decided to also publish some of this as blog posts. These are still a work in progress, but I promise they will make their way there. And I'm also working on some different libraries. So Rio, which is a re-implementation of the Scala Z IO monad. So this is the thing I talked about in the very beginning about writing pure code and having an interpreter which takes these commands and executes them safely. Another challenge we had in our project is that there were no real like good bindings for React navigation, but we made it work. And I think the new hooks implementation of React might solve some of the issues that have been there. Rehooks is just an experiment I'm doing in terms of encoding correct usage of hooks within the type system. Refocus is a way of looking into can we create the concept of lenses in an easier way. And then I've also been iterating in our internal code base on Reason Expo. So there is already a Reason Expo library. It's great. We've been using it, but you can kind of see that it's like a direct implementation of the JavaScript APIs. All right, so I also, in my spare time, run a lot of meetups. So React Copenhagen is one, and ReasonML Copenhagen is another one. And this is our logo. Our little mascot is the reasonably sized mermaid, not the little one. And I encourage you all to participate at a local meetup if you get the chance. And arrange a dojo, which is basically a get-together where you just work on the same project in small groups, and then in the end, you share your challenges and what issues you had, and you get to see how people implemented like the same task in different ways. So I've previously participated in a dojo in San Francisco, and it was one of my like all-time favorite meetup moments. And we also uncovered a lot of improvements that could be made to ReasonML to make it easier to consume. So to end with, this is a call to action. I think you should question the status quo. Think about, is this the right way of doing things? And be open to different ways of doing things. And at last, also contribute if you can. It doesn't matter like how small or how big. It's just important that there's community engagement, so you can get this, so you can get the same escape velocity as TypeScript has had. All right, thank you.